Welcome to the next session of the subject Engineering Maths. We were discussing chapter 3, that is part of calculus, vector calculus. In the last session, we have finished classroom workbook up to question number 80 on line integrals. Now we continue from question number 81 on line integrals. If time permits, we can go for surface integrals also in this session. Okay. So let us start the session with classroom workbook based on line integrals from question number 81. Go through question number 81. Let I equal to integral 2z dx plus 2y dy plus 2x dz over C. Now what are x, y, z? They are real numbers. X, y, z are real numbers. And C be the straight line segment from the points A, that is 0, 2, 1 to the second point, that is B is 4, 1, minus 1. Now this is my line integral 2z dx plus 2y dy plus 2x dz. Now here we need to find line integral over the curve C, where C is a straight line segment joining these 2 points. So A is 0 to 1 and B is 4, 1, minus 1. Then the value of I is. So it's a blank question. Let us handle this. Now when you want to find line integrals, if C is a line joining of two 3D points, then how to handle this? Find the curl of this vector. Basically this is F1 and this is F2 and this is F3. Now what is my vector F bar? F bar is F1 I bar plus F2 Z bar plus F3 K bar. This is my vector F bar. So what is F1? 2Z. This is 2Z I bar plus F2. 2Y Z bar plus F3. This is 2X K bar. Now let us find the curl of this vector. Curl F bar equal to del bar cross F bar. This is by definition. Now this is what? This is nothing but a 3 by 3 determinant. So the first row is unit vectors I bar, Z bar, K bar. Second row is components of del vector dou by dou x, dou by dou y, dou by dou z. And third row is components of F vector. They are F1, F2, F3. So therefore they are 2Z, 2Y and 2x. Now let us simplify this. Therefore in this case curl F bar equal to, this is I bar into dou by dou y of 2x 0, dou by dou z of 2y, it is 0, minus j bar times dou by dou x of 2x, this is 2, minus dou by dou z of 2z, it is 2, plus k bar times dou by dou x of 2y 0, minus dou by dou y of 2z, it is 0. Now this here called F bar is a null vector. So we are luckiest because called F bar equal to null vector. So therefore in this case F bar must be equal to gradient of some scalar pi. Now my task is to find the value of pi. This is a scalar in the variables x, y and z. So how to get this? This pi can be obtained by considering three equations. Dou pi by dou x equal to F1, dou pi by dou y equal to F2 and dou pi by dou z equal to F3. Now what is this F1? F1 is 2z. So this is 2y and this one is 2x. This one is 2x. Now when you look at the second equation, dou pi by dou y is 2y. That means pi is nothing but y square. Integrate this, we'll get y square. Now here dou pi by dou x equal to 2z. When you take pi value from this, you can guess like this, pi value as 2zx. But it will fulfill only the first equation. It may not satisfy second equation. So for that I call it as this is pi 1. For example, only by solving this equation I am getting solution, that I call it as pi 1. So just separate the variables. So you will get pi 1 equal to 2zx. So just you find dou pi 1 by dou x, you will get 2z only. So from this you will get pi 2 equal to, pi 2 is obtained by solving only second equation. Integral 2y is y square. Now pi 3 is obtained by solving last equation. This pi 3 is nothing but this is 2xz. Now when you observe this, pi 1 and pi 3 both are same. So whenever a quantity repeats twice, you don't take it twice, you consider only one time. But y square is repeated only one time. Therefore the value of pi is y square plus 2xz. This is the value of pi in terms of xyz, y square plus 2xz. Therefore, according to fundamental theorem of line integral, this line integral f bar dot dr bar over c equal to, this is a pi of second point. The second point is b and the first point is a. So this is a pi of b minus pi of a. So this is a pi of, what is b? 4 1 minus 1. So this is 4 1 minus 1 minus, this is a pi of a value is 0 to 1. Now let us simplify this value. So what is pi of 4 1 minus 1? Here pi of 4 1 minus 1. This is x value, this is y value, z value. So what is pi value? Y square plus 2xz. Y square plus 2xz. Y value is 1 plus 2 into x into z. So this is minus 8. So this is minus 7. Now what is pi of first point a? That is 0 to 1. So this is again y square plus 2xz. This is y value is 2. So this is 4. Anyhow, this is 0. So here this value is 4. Therefore, this value is minus 7 minus 4. So therefore, in this case, the value of final line integral is minus 11. So just we got this by using fundamental theorem on line integrals, right? See, remember always one point, when you are trying to find line integral, if C is a line joining of two three-dimensional points, immediately find curl of that vector. If curl of equal to null vector, that vector must be equal to gradient of some scalar. Now my task is to get the value of pi in terms of xyz. So in this case, it is happening exactly. Curl of this vector is null vector. So therefore, f bar must be equal to grad pi. So therefore, when you consider these three equations, we got pi value equal to y square plus 2xz. This is a scalar in terms of x, y and z. Therefore, this line integral according to fundamental theorem is pi of b minus pi of a. So when you simplify this, we were getting minus 11. Okay. So note this. Hope you understand this question. Next we move to question number 82. The value of a line integral 2x y square dx plus 2x square y dy 2x square y dy plus dz along a line joining the points 0 0 0 and 1 1 1 and 1 1 1 is options are given. Now this will be exactly similar to previous question. So here C is a line joining of two 3D points. We call it as this as P1 and this as P2. So here what is my F bar? F1 I bar plus F2 Z bar plus F3 K bar. This is F1. So here F1 is 2xy square. F2 is 2x square y. And here F3 is a constant 1. So this is simply K bar. Here F3 is 1 only. This is F1. And this is F2. And here F3 is the constant 1. So as usual, since C is a line joining of two 3D points, let us try to find curl of this vector. Now curl F bar equal to del bar cross F bar. Now the components of F vector are like this. So this is a 2xy square. This is a 2x square y. This is 1. Now anyhow, when you try to find curl of this vector, so I bar times dou by dou y of this, dou by dou y of 1 0 minus dou by dou z of this 0 minus j bar times dou by dou x of this minus dou by dou z of 2xy square, it is 0 plus k bar into dou by dou x of 2x square y. This is 4xy. Here also you will get 4xy. So therefore this quantity is 4xy minus 4xy. Anyhow, we are getting null vector. So here also we were very happy because curl f bar equal to null vector. The difficulty comes when curl f bar is not a null vector. In that case, we cannot apply fundamental theorem on line integrals. Therefore, f bar equal to grad phi, dou pi by dou x equal to f1. What is my f1? 2x y square. Now, f dou pi by dou y is f2. This is 2x square y. Dou pi by dou y dou z equal to f3. Here f3 is 1. Now let us simplify the value of pi in terms of x, y and z. Now let us concentrate on pi 1, pi 2, pi 3. See here pi 1 is obtained only by solving this equation. Here dou pi by dou x. When you integrate to x, x squared term will come. Yes or no? Therefore this will be x square y square. Here also dou pi by dou y. Here I have 2y term. What is integral 2y with respect to y square, but x square term is there. So this is x square y square. Now here dou pi by dou z is 1. So therefore pi 3 becomes z only, because when you integrate 1 with respect to z, you will get z. Now when you look at this, pi 1 and pi 2 are repeated. When a term repeats multiple times, you consider only one time. If it is repeated only one time, you consider only one time. Therefore, here the value of pi is x square y square plus z. This is pi value in terms of x, y, z. Therefore, this line integral is, we can write it as integral f bar dot dr bar over c. This line integral is pi of p2 minus pi of p1 by using fundamental theorem on line integrals. Now this is 1, 1, 1, p2, 0, 0, 0 is p1. Now when you simplify this, the value becomes 2 minus 0, this is 2. Therefore the final line integral is 2. Therefore option B is right answer. Option B is right answer. Note this calculation. Question number 83. A scalar potential pi has the following gradient. What is the gradient? Del pi. This del pi is given as the vector yz I bar plus xz j bar plus xy k bar. So here pi is a scalar potential which has the following gradient like this. Del pi is given by like this. Here scalar is not given, but its gradient is given in terms of a vector yz I bar plus xz j bar plus xy k bar. Consider the integral del pi dot dr bar over c. What is r bar? The standard position vector. This is given as xi bar plus yj bar plus zk bar. Now the curve C is parameterized as follows. So x value t, y value t square and z value is 3t square and limits of t are 1, 2, 3. Then the value of this integral is. So this is purely based on parameterization of a curve C. Now let us handle this. Here when parameterization is given, what is my advantage? All variables are expressed in terms of a single variable t, and another advantage in this case is the limits of t are constant limits. Okay. Now let us handle this. Now assume that this is del pi is a vector f, for example. This is my vector f bar. Therefore, we need to find this vector, this line integral f bar dot dr bar over c. R is a standard position vector. All variables are expressed in terms of a single variable t. T square, 3t square, limits of t are 1, 2, 3. Now in this case, when the question is given like this, we have a direct formula. See that this line integral becomes like this. This line integral f bar dot dr bar over c is nothing but integral, what are limits of t? 1, 2, 3. So integral 1, 2, 3 f bar of r of t dot r dash of t dt. Now this is a dot product. What is this f bar? It is a vector when x is replaced by t, y is replaced by t square, and z is replaced by 3 square. R dash of t, you can find a vector in terms of t. At first, let us see what is this. Here r of t is basically the vector xi bar plus yj bar plus zk bar. Now what is x? It is t. So this is a ti bar, y value t square j bar, z value 3t square k bar. So here r dash of t, this is r of t. Now r dash of t, that means to differentiate this derivative of t with respect to t, 1. So I bar, this is 2t j bar plus 6t k bar. I bar plus 2t j bar plus 6t k bar. Therefore, this integral becomes integral 1 to 3 f bar r of t. So this is yz. Here I call del pi as f bar. Now replace x value, y value, z value, in this case yz, that is 3t square into t square, 3t power 4. So 3t power 4 I bar plus next one is xz. What is xz? 3t cube. So 3t cube z bar plus next one is xy. Multiply this, we will get t cube. So t cube k bar. Now this is nothing but f bar of r of t. This is f bar of r of t. Now r dash of t is this. So therefore this becomes I bar plus 2t j bar plus 6t k bar dt. Now this is a dot product. Now therefore when you simplify this, this becomes integral 1 to 3, 3t power 4 into 1, 3t power 4 plus 3t cube into 2t, 6t power 4 plus t cube into 60, 60 power 4 dt. Now we got a scalar in the variable t. Now add this, you will get 15t power 4. So therefore this is integral 1 to 3, 15t power 4 dt. Now therefore this is nothing but 3t power 5. Limits are from 1 to 3. So 3 into apply upper limits. This becomes 3 times 3 power 5 minus 1. So therefore the final value is integral f bar dot dr bar over c. This is given by 3 into this 3 power 5 is 243 minus 1. So this is 3 into 242. So therefore the value is 726. Therefore the final for required line integral is 726. This is simply parameterization of a curve. Okay. So note all these points. Question number 84. Let R cube denote the three-dimensional Euclidean space and f bar is given by minus yi bar plus xj bar plus zk bar. So this is my vector minus yi plus xj plus zk bar. If C is the curve described by the parametric equation R of t equal to cos t into I bar plus sin t into j bar plus 2t square k bar. Here limits of t are 0 to 1. Then they were asking the line integral f bar dot dr bar over c. This is a numeral question. Now here also this comes under a parameterization of a curve. Now you can see this is x value. So x value is cos t. Y value is this coefficient of j bar sin t. And z value is coefficient of k bar. This is 2t square. And limits of t are 0 to 1. So a parameterization is given. Therefore, in this case, the line integral becomes, that is, integral f bar dot dr bar over c. This becomes integral, all variables are converted in terms of a single variable t, limits of t are 0 to 1. So this becomes integral 0 to 1 f bar of r of t dot product r dash of t dt. Now therefore, this is integral 0 to 1. Now what is f bar? This is minus y I bar. I minus y is sin t. So minus sin t I bar plus x is cos t. Cos t is a bar plus z value is 2t square. So 2t square k bar dot product with r dash of t. Now this is r value. Now here r dash of t. Differentiate this. Cos t is, I will write it as a pointwise representation. Cos t derivative minus sin t. Sin t derivative cos t plus comma 2t square derivative 4t. Now this is r dash of t. This is coefficient of I bar, coefficient of z bar, coefficient of k bar. So here cos t derivative minus sin t derivative cos t, 2t square derivative 4t. Therefore this r dash of t is minus sin t I bar plus cos t z bar plus 4t k bar dt. So therefore this becomes integral 0 to 1 minus sin t into minus sin t sin square t plus cos t into cos t cos square t plus this is 2t square into this is 4t 2t square into 4t, this is 8t cube dt. Now cos square t plus sin square t is 1, so this is integral 0 to 1 integral 0 to 1, this becomes 1 plus 8t cube dt. Now let us cross check this whether it is right or not. So this is minus y, this is sin t minus sin t, x is cos t plus z is 2t square. So minus sin t plus cos t plus 2t square j bar. Now its derivatives are cos t derivative minus sin t derivative cos t, 2t square derivative 4t. Therefore minus sin t plus cos t plus 4t, minus into minus plus, cos into cos, cos square t, 2t square into 40. Yes, this is right calculation. Now integral 1 dt, this is t. Integral 8t cube, this is 2t power 4. Limits are from 0 to 1. Now replace t by upper limit, this is 1 plus 2 minus 0 plus 0. Therefore this is 3. Therefore final required line integral is exactly 3. Just like previous model. But here R value is expressed in terms of trigonometric functions, sine, cos, and rest of the thing is a polynomial expression. Note this. Now next question, question number 85. The value of integral f bar dot dr bar over c1 minus integral f bar dot dr bar over c2. So here we need to find two line integrals. F bar is fixed, but curves might be different. So both are two different line integrals. Now what is C1? C1 is given like this. C1 column R of t equal to t comma t square. The C2 curve is described by like this. R of t equal to t comma square root of t, and limits are from 0 to 1. And what is my f bar? This is nothing but xy into z bar. Then what is the value of this difference of these two line integrals? Now when you look at this line integral, the function is, the vector is fixed, f bar is fixed. It is given only in terms of xy. There is no z component. Here this is curve parameterization. X value t, y value t square for C1. X value t, y value root t for C2. But limits are fixed. 0 to, for both the curves, the limits of t are 0 to 1. And for both the line integrals, the vector f bar is fixed, x, y, z bar. So you need to find this by using parameterization and this by using parameterization. At first, let us try to find this. Integral f bar dot dr bar over c1. Now this is nothing but integral 0 to 1 because limits of these t are 0 to 1. This is f bar of r of t dot product r dash of t dt. So therefore this is integral 0 to 1. Now this is x value, this is y value. X into y, t into t square, t cube z bar dot products r dash of t. Differentiate this derivative of t1. So this is I bar plus t square derivative 2t dt. Therefore, integral 0 to 1 dot product this followed by dt. Simplify this t cube into 2t. So this is 2t power 4. Limits are from this is 0 to 1. Limits are from 0 to 1. Let us cross check this. This one is t square. This is t root t. So this is xy I bar. So in this case, this is only 2t power 4. This is not integral. This one is integral 0 to 1 2t power 4 dt. Now apply integration. So this is 2 times t power 5 by 5. Limits are from 0 to 1. Therefore, this line integral is 2 by 5. The first line integral is 2 by 5. Let us evaluate second line integral. So the second line integral is f bar dot dr bar over c2. This is again limits are from 0 to 1. What is f bar? This only. So xy is a bar, but x is t, this is root t, t into root t. So this is t power 3 by 2 into z bar dot product r dash of t dt. This is differentiation of t with respect to t. So 1, this is 1 into I bar root t derivative. This is 1 by 2 root t z bar dt. So therefore, this is integral 0 to 1 t power 3 by 2 into 1 by 2 root t. So this is t power 3 by 2 means 2 root t. So therefore, this is t by 2 dt. T by 2 dt. Therefore, this is nothing but t square by 4. Limits are from 0 to 1. Therefore, this is 1 by 4. So the first line integral is 3 by 5, 2 by 5, and second line integral is 2 by 4. Therefore, the final result is so this is 2 by 5 minus 1 by 4. Difference LCM is 20. So this is 5 fours, 4 twos 8. This is 4 fives. So this is 5. So therefore this is 3 by 20. So therefore the final result is 3 by 20. Number 86. The value of the integral I equal to integral x minus y dx plus x square y dy over c, where c is the boundary of a square 0 less than or equal to x less than or equal to 2, 0 less than or equal to y less than or equal to 2. We need to find out this line integral, integral x minus y dx plus x square y dy over c, where c is the boundary of the square. X limits are 0 to 2, length is 2. Y limits are 0 to 2, breadth is 2, length is 2, breadth is 2. So it's a square. So we need to find out this line integral. Okay. So basically this is previous question. This is 85. Now let us come to this. You can limits of one advantage with this problem is limits of x and limits of y are constants. Therefore, this we can call it as p, and this we can call it as q. Therefore, by Green's theorem, this becomes double integral dou q by dou x minus dou p by dou y dx dy over the curve C. Therefore, this becomes, here curve C is described by these two values. So x limits are 0 to 2, y limits are 0 to 2, dou q by dou x 2xy minus dou p by dou y. This is minus of minus 1. So therefore this is 2xy plus 1 dx dy. So therefore this is integral 0 to 2, integral 0 to 2, 2xy plus 1 into dx dy. Now here the advantage is all the limits of x and limits of y are constants. When you are integrating a function of two variables between x and y, you can take any rule because all limits of x and limits of y are constants. Order is not an important. You can do integration with respect to x first followed by y, or with respect to y first followed by x. Therefore, this becomes integral 0 to 2, integral 0 to 2, 2xy plus 1 dy whole dx. That means we were integrating with respect to y followed by x. Therefore, this becomes integral 0 to 2. So with respect to y, that means this is xy square plus y dx. So replace y by upper limit. This is integral 0 to 2. Y limits are 0 to 2. So this is 4x plus 2 dx. So therefore this is 2x square plus 2x limits are from 0 to 2. So therefore this is 2 into 2. 2 square 4 2 is 8 plus 4 minus 0 plus 0. Therefore the final line integral is 12. This is just by applying Green's theorem.